Hello, intrepid researchers. Hope you're doing well. I hope that you're thinking carefully about your projects this week as we move into a new phase of the research process. Today, we're thinking about moving from the theoretical world of expectations and the devising of hypotheses and the statement of sort of official positions about what's going to happen, our null hypothesis world, our main hypothesis world. We're moving away from that conceptual world to the process of research design. And so by research design, I mean the answer to the question, well, how the heck are we actually going to study this, right? How are we going to perform a study of these kinds of questions? So if we've got these topics, for example, what explains variation in European countries' rates of voter turnout? How do we find out the answer, right? How do we determine with certainty that, religiosity explains variation in European countries' rate of voter turnout? What explains variation in Americans' belief that the economy is strong? Maybe that's your household income. Does that actually hold out? We want to know whether or not these things actually have real observable relationships in the world. And so to do that, we have to have a plan, okay? The question we want to contend with today is, how do we answer the question? How do we determine whether or not our hunches, our theories, have support in the observable or empirical world? And so, of course, we have all creative research questions already in Poly 301. Good job. We've done that. I've read your research questions. I've vetted them. I've made sure that they are appropriate for this analysis. And if I've told you that your research questions are really good, and that means that you are well positioned to be able to fulfill all the requirements for upcoming compositions. And so you may not have heard of this before, but I'm here to tell you that you will be performing in order to determine whether or not your theory holds up, whether or not your main hypothesis or your null hypothesis really carries the day here in terms of the real empirical world. Both a quantitative analysis of 50 or more units of observation and a qualitative analysis of two key cases of that set of observations or of the population of your study, where you'll be able to further evaluate and understand whether or not your theory holds up under empirical scrutiny. So we're going to be doing both a quantitative analysis, a large N, what we call large N, meaning a large number of observations, a quantitative analysis that uses statistical tools, uses RStudio, uses all those fancy stats applications we have, and the statistical tests that allow us to say with certainty whether or not we have evidence to support a conclusion, and a qualitative analysis where we'll do a deep dive and get into two specific cases and try to figure out, through a thing called process tracing, whether or not our theory makes any sense once we look into the details of specific relationships. So get excited. That's what we're doing in this class. We're going to do both. Many scholars in political science will do quantitative analysis exclusively. Many other scholars will do qualitative analysis exclusively. And that doesn't necessarily mean that one is better or worse than the other. As we'll see, I think that having both, doing a multi-method research design in this class, means that we will be able to leverage even more knowledge of the empirical world to determine whether or not our theories have support in empirical reality. So both a quantitative analysis of at least 50 unit observations, so we'll see again what I mean by 50 or more unit observations, and a qualitative analysis of two key cases. So again, thinking about quantitative research designs for just a moment, again, quantitative research designs are about analyzing the statistical association. So quantitative meaning numbers, the statistical association between variables. These are operationalized numerical variables, number representations that represent your IV concept and your DV concept. And so for each case, for each individual, for each country, for each state, for each city, for each whatever, we're going to have a number to represent the IV concept, we're going to have a number to represent the DV concept, and we're going to look at the association between those numbers for all of our cases together and determine whether a pattern emerges. And so what we're ultimately trying to construct here is what we might call a flat data set. Flat meaning that this is where rows measure individual units and the columns measure different variables. And so I'm going to show you an example of one of those in just a second here. So you may remember this data set from the tap list exercise that we did in class when we were first introducing RStudio. I like this little example data set because it is a data set consisting of a whole bunch of beers. And you'll see that this is basically from a menu from a restaurant that has a whole bunch of different beers from places in the area. I actually just took this from, again, just a random restaurant in South Baltimore that I tend to go to eat. And I said, hey, look, here's a bunch of data on beers. You can see that this data is a flat data set that's rectangular, which means that it's in exactly the right shape for us to analyze. In the very first row here, we have column names. So this is the name of the beer, this is the type of beer, the size of the beer in terms of ounces, the alcohol by volume of the beer in terms of its percentage, the state of origin is just called origin in here, the brewery, the specific brewery, and then most importantly, of course, the price in dollars. And so for each of these columns, we have a variable, right? Each of these columns indicates one feature, one concept that relates to each individual beer. Type, size, alcohol by volume, origin. But for each row after the first one, which is just the names, we have an entry of a single observation. So for example, Fat Tire is a beer that's brewed in Colorado by New Belgium Brewery. It's $5 at this restaurant, and it's 5.2 alcohol by volume for 20 ounces of an amber beer. And so we can learn everything that we can in this data set about Fat Tire by looking at a specific row, whereas we can learn everything we can about the entire data set's types of beer by looking at every column. So this is where we're headed. For any project, no matter what it's studying, we're looking to create a flat rectangular data set where columns indicate different variables, right? You might have each individual observation's name here. Maybe these are countries. You've got Norway, you've got Belize, you've got Equatorial Guinea, whatever. Maybe here you've got the GDP per capita of those different countries, or here. And then maybe here you've got the, Democracy Freedom House score for how democratic that country is. Regardless, it's still the exact same shape. It's every row is a country and every column is a variable. So that's where we're headed. That's the idea, is to get this. You'll see, though, that this data set that I've got here, this little practice data set, is not sufficient, actually, for our project. Of course, it's not sufficient because it's also not about politics, at least I don't think it is. But it's also only got 32. You'll see it's got 33 rows, but the first row is not an actual observation. It's just the names of these variables. It's got 32 observations. We need at least 50. So in a large N analysis, we want our data set, our flat data set, to be long. We want it to contain at least 50 observations to go all the way down this Excel sheet and fill in the variables here. And so again, if we wanted to look at, say my research question was, do more boozy beers have higher prices? I'd be able to look at the association between these two things, these two columns, through a correlational analysis. Now, if I thought that some other variable was important here, like maybe we have to consider that size could matter as well, where bigger beers also might be more expensive because you're getting more, then we've got to think about other statistical tools that we could use to analyze this relationship in the presence of or compensating for differences in size or differences in type or differences in origin. So again, we're going to return to this example later, but I just want to show you, just really lock in this idea that in any flat large N data set, for every column, we've got a variable, and for every row, we've got a case. So as we were just mentioning, we're going to use statistical tests to analyze our specific hypotheses that we've stated at the end of our theory sections using these flat data sets. And so again, we might be interested in additional analyses that actually accommodate more variables than just the IV concept and just the DV concept. But we're going to have to wait to see whether we can collect those data for the units that we have in our study. And of course, we have to make sure that we have at least 50 of those units. In comparison, a qualitative analysis, instead of being long, like we were talking about having many, many, many rows in a data set, the qualitative analysis is deep. It takes only a couple of observations, and it gets into what we call thick descriptive investigation, where we get into the details of these cases. We get intimately familiar with all of the properties of those cases, far beyond just the columns of a data set. We get into a really deep, familiar knowledge of those specific cases and all the different things that are going on in those cases that pertain to the theory that we've specified. And so the nature of our specific qualitative methods, the way that we're going to go in depth on a couple of cases, is going to depend on our level of analysis. And so remember, we talked about changing the magnification of the microscope in our study to determine whether we're looking at individuals or whether we're looking at states or cities or counties or countries or media markets or any larger level of analysis beyond the individual. If we're looking at individuals, we're going to be performing interviews with at least two people that we know or that we recruit who might plausibly fall into our populations. So if our population happens to be Gen Z Americans, you're going to have to find a couple of Gen Z Americans to talk to. And hopefully that won't be too difficult, especially because you could get them on Zoom or you could get them on a phone call or anything in order to conduct these interviews. If your population is Iranian American mothers between the ages of 50 and 70, then you're going to have to find a couple of Iranian American mothers between the ages of 50 and 70. So it might be a little harder for you to get two individuals in the data set. But again, all of this is flexible. We're building the airplane while we're flying, so you can change the population parameter if you think that it's going to be hard to get two interviews with those specific people that you're interested in studying. If the research question is comparing states, if it's comparing cities, counties, countries, whatever, you're looking at the state, you're looking at the city, the country, you're going to be doing in-depth primary and secondary source research into the properties of those specific cases. And I'll show you some examples in just a moment to help you understand what I mean by that. Now, why are we doing this? Again, I think it's important to consider that multi-method research allows us to overlap some of the strengths and also cover some of the weaknesses of these individual methods. So of course, qualitative analysis is going to give us this really deep insight into our IV and DV concepts. But again, one of the problems potentially, one of the criticisms of qualitative analysis is that it's not really super generalizable. If you talk to two people about this analysis, you learn a lot about those two people and about their, the things that concern them and about the deep links between the theoretical variables that you're considering. But, if even one of those people tends to see this from a very non-median perspective, if by the luck of the draw you got somebody who just doesn't represent the population at all for some reason, then that means that your insights might not generalize well to the full population. If you think about quantitative analysis, right, the strength here is that it gives us this generalizable insight. We're able to say something a little bit more structured about a population as a whole and make an inference to the level of that large population. But we lose so much in terms of the abstraction of our IV-DV link. Like, think about analyzing the correlation between two survey variables. I mean, do those survey questions really speak to the true nature of the concepts we're trying to measure? Maybe not always. And so having both, right, really gives us the ability to both be wide, be generalizable, and be deep in terms of looking at the association that we care about. So multi-method research is a really strong and powerful tool. Not to mention, in a class like 301, we want to learn as many approaches as possible, and we want to know what modern political scientists are actually doing in their work. And it turns out that modern political scientists are, lo and behold, doing both and many more other types of research in modern times, including experimental research, which we'll talk a little bit more about, in terms of doing all kinds of text analysis and other kinds of content analytical research. And they're doing even more, going beyond that. They're doing anthropological research, they're doing historical archival research, all kinds of different forms of research. This is just a taste, but I think these are two of the most important types of research that we can contend with in our studies. So I want to give you a couple of examples. I think this is always really helpful to just absolutely bury people in examples, because you'll get a gist for how your topic might line up or differ from these by looking at them. So, for example, I've got a research question here. Does religiosity explain variation in European countries' rates of voter turnout? So here, the unit of analysis who we're looking at is whole European countries. We could say we've got the 27 countries in the European Union, for example. We might ask ourselves, well, we might have some national level demographic statistics on how religious a country is. Like we could look at what percentage of members of those countries regularly attend religious services of any kind. We could look at that number, that's a percent, and we could look at its relationship to voter turnout as a percent. And so we've got this nice correlation that we could do where we've got a data set. Think back to that Excel sheet. Every row is a country. We've got one column where every entry is the percentage of religious in the country, and then another column where every observation is the rate of voter turnout in that country. However, we got a problem here because the European Union, if we're looking at 27 member states, then we don't have enough observations to get to that 50, which is the magic number that I have assigned to us to indicate that we're doing truly large N research. And of course, that's because if we're doing regression analysis, which is the primary statistical tool that we'll be using in the future to conduct our analyses, that regression analysis tends to be really unreliable if we have less than about 12 cases for every variable that we include in the study. So we definitely want to make sure that we have at least 30, but if we're building out a full model with a number of variables in it, we're going to definitely need at least 50. So 50 it is. We're going to need to do something here in this example to build out the number of cases beyond just 27. And of course, we could potentially look at this relationship across the whole world. We could change the level of the scope of our population. That would be fine. We get hundreds of countries in our data set. Or if we're really committed to the European Union as a specific population, we could look at repeated observations. So we could do the same measurements in 1980, in 1990, in 2000, in 2010, and 2020. 5 observations per country would get us up to 135 observations. So again, even though we're only looking at those same 27 countries, our N in the study, again, the rows in our data set, because we're doing it 5 times for each country, ends up being 135. So that would be a very suitable strategy for this study. Get 135 observations of religiosity and voter turnout. Presumably these things do change somewhat over time as well. And then we're able to make a really nice inference about this relationship. But of course, we're not done, right? We've got to go further because we've got to do qualitative research as well. And so in the qualitative section of a paper with this research question, we could look at into a historical investigation of the groups themselves, the religious groups and even non-religious groups, and their official stances towards political participation in 2 countries, maybe a country with very high levels of religiosity, maybe a country with fairly low levels of religiosity, and look at their voter turnout as a result. And so, again, this isn't just looking at the 2 statistics and saying, okay, look, we saw that religiosity was high in this country, and here's the voter turnout, and I looked at those percentages like really hard or something. I read them with great gusto in the data set. No, we want to go beyond. We want to say, okay, but who are the religious people in these countries? Are there Catholics in Italy? Are there Muslims in Italy? Are there people of other different faiths? Are there Protestants in the Netherlands? Are there Muslims in the Netherlands? And what are the imams? What are the cardinals? What do the religious leaders in these various countries say about what their parishioners should do in terms of getting involved in politics? Do they make explicitly political statements? Do they pressure their members to turn out to vote, or do they say we shouldn't be involved in the politics of a country? Our eyes are on heaven or something. How does this work in a country? So the idea is trace the actual process by which you get from one part of your theory to the outcome by looking at the detailed specifics of these individual people on the ground in these countries. So you go much beyond just the percentages or just the individual numbers in the data set to really think about what's actually happening in the Netherlands and what's actually happening in Italy in terms of religious communities and their stance towards political participation. That's one example of this, where we've got both a quantitative aspect of this and a qualitative aspect. Here's another one that's at the level of individuals. Ask the question, does household income influence variation in the belief that the economy is strong? So looking at economic perceptions. And so a quantitative analysis here, because we've got Americans as the population, we're going to need some kind of survey, because especially we're talking about beliefs here. So we could look at this, right? We could find an analysis or we could perform an analysis of an existing survey of Americans that was conducted in 2019. So a recent survey with 1,000 people in it, 1,007. Maybe this is some kind of CPS supplement, the consumer population study. Current population study, excuse me. The CPS, we could have some kind of supplement here that we got from the Bureau of Economic Analysis or some other government source, or we could use the GSS or the American National Election Study. We're going to get into this later about where to find this data. But if we find a survey, whatever it's called, whatever series it's part of, where we're able to download that data and get the rows and the columns that we need to perform that analysis, we could find a variable that asks people, what's your yearly household income to the nearest $1,000? And we could also find another column in the data set, another variable, that asks people to say whether the economy is doing better than average, worse than average, or about average. So maybe a variable that takes 3 levels, where 1 is better than average, 2 is about average, and 3 is worse than average. And so then we've got, again, those 2 numerical scores that we need to perform a quantitative analysis of 1,000 people. And so there we go. We can do large N statistical analysis, given the fact we found a survey with the appropriate questions. For the qualitative analysis, this is a little different, because we want to now focus on the lifestyles and the thoughts and the opinions of 2 individual people. So we could think about choosing 2 people, maybe a couple people, maybe somebody with high household income, maybe somebody with low household income, and ask them, how's the economy doing these days? How do you know? Why do you think that? Tell us. Give me 30 minutes of your time and just pontificate about what's going on with the economy today, and get a really deep, fine-grained understanding on the basis of these structured interview questions about how it is that household income influences the way that people observe the economy. Maybe people really think about their pocketbooks when they're conceiving of the state of the economy, or maybe they don't. Maybe they look out there and they think about the average person who's not necessarily themselves, and they ask themselves that question of whether the economy is doing well for that average person. So again, the qualitative analysis goes much further than just numbers in a spreadsheet to get people to tell you about their understanding of how financial experiences shape their understanding of the broader economy. So it's again, 2 very different approaches to answering the same question that gives us wide and broad and generalizable data, and also that gives us deep and detailed and fine-grained and thick description as well. We'll do one more here before we say goodbye for now. This question is, does divided government influence the speed of COVID-19 vaccine distribution in the United States? And so by divided government, I mean essentially that the state legislature or the chambers of the state legislature are not the same political party as the governor. Or the governor and one chamber are the same, but the other chamber is different. So basically the idea is that you've got both Republicans and Democrats who hold at least one veto point, or at least one stronghold of power in a state's constitutionally derived checks and balances of government. So does divided government, if you do have a state like that, like for example Maryland, we've got very large majorities of Democrats in the state House, right, in the state legislative chambers, but the governor, Larry Hogan, is a Republican. We have divided government in Maryland. So the question is, does this divided government, maybe the governor and the state legislature squabble about how to do the COVID vaccine? You have a theory about this, and you think that the divided government is going to decrease the speed or increase the delay or decrease the speed of the COVID-19 vaccine distribution. Whereas regardless of which party it is, if you've got unified government, then there's no checks and balances to stop you, and things tend to flow more smoothly. And so a quantitative analysis would look at each state's government status. So you'd have to go through, you got 50 states. Every row in your data set is a state. And you go through, you construct this variable. You say, okay, Maryland, divided or not divided? Okay, divided. So maybe 1 for divided, 0 for unified. Pennsylvania, divided, not divided, and you assign that one. Colorado, divided, not divided. And for every state, you've got a 1 or a 0 in that data set for whether it's divided. Conveniently, you got 50 states, you got 50 observations. So that means that you've satisfied that large N requirement for quantitative analysis. Your dependent variable, you look at, maybe some measure of how many vaccine doses per capita, obviously scaled to the population of that state, were administered maybe in February of 2021. because that's like early rollout kind of stuff. Like it's not the very first day of vaccine distribution, but it's this kind of period between when it's probably going to be a lot more widely available and when it first started. So that could be your criterion. You could say, I'm looking at February of 2021. I want to know in that whole month, what percentage of the population of that state basically got vaccinated. And so you can compare it, right? You can do that same quantitative analysis. You can figure it out. You can build in a regression model where you also compensate for other variables that might also influence how fast people get administered vaccines in additional variables that you construct in that data set. And we can find out the answer to the question. Do we have statistical support for that theory or do we not? But we might also want to go further, as we've said, and engage in a qualitative, in-depth analysis of maybe two states where maybe vaccine rollout was good or bad, or maybe where divided government and unified government differed. So Maryland with a divided government, Connecticut with unified government. And that would be, again, not just looking at the percentages, but going in depth and saying, like, what did Hogan say? What did Hogan do, right? Did the state legislature try to block him? Did they agree with him? Was there a problem here in terms of distribution that came from divided government? What happened in Connecticut? Did it happen really quickly? Was the rollout successful? Were there conflicts in the state legislature and between the governor, even though they might have had the same political party? And again, really get into the history and the details of those specific cases. So with the qualitative analysis, you can't just look at the main data. You got to get into the case and figure out what really happened. So those are all the research designs that I have as examples. But I do want to just close by just mentioning again, right? With the quantitative part of the analysis, you've got some questions to answer. If you've got an individual level analysis, you're going to have to answer the question quickly. Where are you going to find survey questions? Survey questions that contain, again, at least one question where your IV concept is measured, at least one question where your DV concept is measured, or at least a reasonable proxy. And you got to make sure that this survey samples members of your population. The survey might sample more than just your population. It might sample a broader group than who you're focusing on. But you got to make sure that there's at least a few people in there that belong to your population. And then also, you might think, hey, if I've got some lurking variables out there, some so-called third variables that I need to control for, do we have questions that will also fit from that survey? Because, again, you can't take questions from two surveys and combine them because they're not asking the questions of the same people. For those studies, you're going to have every variable, every column in the data set deriving from one survey. If you're at the state or the city or the country or whatever level, some higher level, you're going to want to look at these aggregate measures. And so just like the last example we saw of COVID cases and stuff, where are you going to find those measures? Where are you going to find a measure of divided government? Is it that those exist somewhere all in a row where you've got like some Wikipedia page or some scholar has produced a list of like, here's all the states where there's divided government and here's all the states where there's not? Or are you going to have to go to like the government websites of each of those states and look one by one and fill in all 50 by hand, right? And again, finally, the other question is, if you don't have 50 units, like say you've got 27 countries, how are you going to be able to expand that analysis to get to 50 units? And the answer to all these questions, if you don't know them, of course, the bigger answer is just contact me and we'll talk about how to fix the problem. The last thing I want to talk about is some questions for you in the qualitative research design. And so if you're thinking about which cases to choose, maybe you were motivated by specific cases. I know I've spoken to many students who have said, the case that really sparked my interest in this general research question was fill in the blank, right? I noticed that this specific country, this is the way things are in that country. I'm from that country maybe, and so that's why I think that way. Maybe like, I observed this specific news story that was about this one state where this happened. Maybe I was talking to this one person even, and they mentioned this relationship between these two variables that got me thinking. You can definitely use a case like that. That'd be totally normal that you use a case that sparked your interest for that qualitative analysis. But again, we need at least two. And so you can think about, for example, a most similar systems design in which you're selecting two cases that are nearly identical, but are not the same in the DV outcome. So for example, if you're comparing cities like Cincinnati and Louisville, like as somebody who's spent a lot of time in Louisville, a while ago when I was in grad school, visiting my wife who was living in Louisville. Cincinnati and Louisville are very similar cities for a lot of reasons. They just tend to be kind of these sister cities. They're both like on the river. They're about the same size. They're in the same region, but maybe they have very different COVID-19 case rates. We want to know, even though these two cities are so similar in so many different respects, why did the outcome differ so much? And so that is a good way to set up a comparison, is to look at the outcomes and say, why are these two cases, which would otherwise be so similar, so different? Another example would be to look at cases where like the Ivy concept or even just broader properties are very different, but have similar DV outcomes. So for example, if you're looking at the question of like, why do some states not apportion electoral votes by statewide margins, Nebraska and Maine are the two states that do that, but they're incredibly different states. Like, the political culture of Nebraska is quite different for historical reasons than is the political culture of Maine. And so these are very different states, but they nevertheless arrived at the same outcome. And so the question is, why did these two different states come to such a similar conclusion? So a most similar system design is one way we could do this. A least similar system design is another way we could do this. Regardless, you're going to want to start thinking about which two cases in my population will offer me the best insight as I do my qualitative section. So again, quantitative, qualitative, and Poly 301, we're going to do it all. So I hope you enjoy that process. I hope you look forward to it, and certainly take a look at the textbook for a lot more information about research design. I'll see you next time.